rubber sheet model of the fabric of space-time that a previous group was talking about. We use this model to represent the fundamental idea of general relativity, that matter tells space-time how to curve, and space-time tells matter how to move. So imagine you have a rubber sheet and you place some sort of mass on it. It curves the surface of the fabric. So anything that's moving along that fabric, its path is going to be curved according to how much the fabric is curved downwards. And in a black hole, just imagine such a great mass that it's stretching the fabric down and down and down as far as you can imagine, so that the curvature is infinite. And the very most curved point is called the singularity. And it creates a gravitational field so immense that not even light can escape it.
Supermassive black holes are millions to billions of times more massive than our own sun. Typically, the bigger the black hole, the less density, and that's because they have a bigger radius. And it's also, as we mentioned before, theorized that at the center of large galaxies, including our own, there are supermassive black holes. When entering the gravitational field of a black hole, the force is greater the closer you get to it. And the force is greater on someone's feet than on their head because the feet are closer to the gravitational body, and it produces a tidal or a stretching force which will pull it until you're just a stream of particles, and then you just get sucked in. And that is called spaghettification.
And that's assuming someone's falling in feet first, so the force is greater on their feet than on their head, so they get stretched out. So in conclusion, black holes are regions of space whose gravitational fields are so strong that not even light can escape it, which is what causes them to be black, because there's no photons or particles of light that can leave. So many galaxies have supermassive black holes at their centers, and this sort of explains why galaxies don't gradually drift apart. It's sort of what keeps them together in clusters. The extreme gravitational field of black holes can literally rip apart objects that fall into them. That's the effect of spaghettification.